In this video, we will look at how vectors can be used in Mobius. Mobius provides a set of inline functions for working with vectors. The functions have parameters where you pass in vectors, and in many cases, they return a new vectors. The vectors that you pass in are never modified. The vector functions are all overloaded. When you pass in multiple inputs, multiple outputs will be returned. Let's have a look at a few examples. Basic vector arithmetic can be performed by using functions to add, subtract, multiply, and divide vectors. For addition and subtraction, the parameters are two vectors. For multiplication and division, the parameters are a vector and a number. Multiplication and division change the length of a vector, but not the direction. A number of other functions exist related to the vector length. To get the vector length, the vec_length function can be used. Do not confuse this with the len function for getting the length of a list. For a vector with 3 components, that function will always return 3. To set the vector length, the vec_set_length function can be used. To normalize the vector, the vec_normalize function can be used. This will set the length of the vector to be 1 unit. The vec_reverse function will reverse the direction of a vector. The result is the same as multiplying the vector by -1. For multiplying two vectors, you can use the dot and cross product functions. The dot product function returns a number. The cross product function returns a vector. For calculating the angle between two vectors, there are two functions. First, let's have a look at the vec_angle function. Remember that vectors have no location, they can float around anywhere. So how can we calculate an angle? We can assume that the vectors are located at the origin. The function will then return the smallest angle between the two vectors. The angle will therefore always be less than or equal to 180 degrees. Since the smallest angle is always returned, the order of the input vectors does not matter. The second function for calculating angles is the vec_angle_2 function. In this case, the function returns the angle from the first vector to the second vector, in an anti-clockwise direction. In order to be able to figure out which direction is anti-clockwise, the function needs to know your point of view. The point of view is specified by a third vector, the normal. In the example, we have two vectors in the xy plane. And the third vector, the normal, is pointing straight up in the global z direction. To figure out the anti-clockwise direction, the function will assume we are looking down at this normal. In this case, the angle that is returned can be larger than 180 degrees. All these functions are overloaded. This means that you can pass in multiple inputs, and multiple outputs will be returned. The example shows how this works for the multiplication function. You can see the results for the different combinations of arguments. Multiplying two vectors by one number. Multiplying one vector by two numbers. And multiplying two vectors by two numbers. Next, let's look at how primary functions work with vectors. There are two primary functions for getting vectors from geometric entities. There is also a third function, for calculating the centroid. It does not return a vector, but we will also cover it here since they are often used together. These functions are all in the calculate category. The calc.vector function calculates the vector along one or more edges. If you pass it a wire, polyline, or polygon, the function will extract the edges and return a list of vectors along those edges. The calc.normal function calculates the vector perpendicular to a face. If you pass it a polygon, the function will extract the face and return the vector for that face. The calc.centroid function calculates the location at the center of the entity. The center is calculated as the average of the xyz coordinates of all the positions in the entity. These three primary functions are all overloaded. Given a list of edges, the calc.vector function will return a list of edge vectors. Given a list of faces, the calc.normal function will return a list of normal vectors. Given a list of entities, the calc.centroid function will return a list of centroids. Let's look at one example, the function for calculating the normal. In this example, we can see a torus shape has been generated, defined by a set of polygons. The list of polygons is passed to the calc.normal function. The argument for the second parameter is set to 1, which means that the normal vectors will all have length 1. When we print the result, we can see that a list of normal vectors is returned. We can see that the values of the three vector components are all less than 1. If the vector is supposed to be 1 unit long, then this makes sense. It looks like the length of these vectors could all be 1 unit. Finally, let's look at how we can visualize vectors. In some slides, we draw arrows to make it clear what is happening. But these arrows are not part of the 3D model. In the example, we get all the polygons in the model and calculate the normal. We can print the result, and we can see that we get a bunch of vectors. But we cannot see the vectors in the 3D view. A vector cannot be visualized since it has no location. So there is no way of knowing where to actually draw the vector. However, if a vector is converted to a ray, then it can be visualized. In order to do that, you need to specify an origin for each ray. In this example, the origin can be the centroid of the polygon. You can create the rays using the raymake inline function, which is overloaded. You can then visualize the rays using the visualize.Ray function.